here on Earth.
Talking about people that would permanently colonize the moon.
I wouldn't call it colonized because there is nobody there. It's just a human base, okay?
Right, yeah.
And they will eventually develop their own culture, very different from what we have here.
Different accent.
Yeah, it's like an island. And then on Mars, it will be a completely different culture. And, that may be a solution to Fermi's paradox. You may ask, where is everybody? Well, people are having, everybody is having fun. They enjoy good food. They enjoy the company of their friends in the place where they are. They don't think that it's necessary to go other places. And that's, perhaps why we don't see them here.
Well, as we understand of physical laws, and maybe we just don't know enough, right? But it seems to be nearly outside the scope of just having, we have a lot of time, right? So that's why the probe theory makes sense, because you can probe, they can replicate, they have hundreds of millions of years, billions of years, but biological life,
wouldn't survive.
It wouldn't survive, and as far as we know, we can't go faster than the speed of light.
No.
Right, and so the idea of aliens in ships, biological aliens visiting, very unlikely.
Yes.
Yeah.
So I think actually you don't want that. I'm proud of our technological kids. I don't care. I go to Harvard Yard, okay, and what do I see? I see monuments. I see sculptures or paintings or past presidents or past deans that wanted to preserve their physical appearance. So they made a statue, okay? But that makes little sense because, as I said before, in 1 billion years, everything on Earth will be burnt up by the sun.
God, stop saying that. You're pissing me off.
So if you want to preserve something of yourself, just send an AI astronaut that replicates your desires, your guiding principles, your blueprint, and will represent you out there. It's just like sending a kid to the world. You made 2 kids recently.
I did, yes.
And they carry your DNA and your wife. And you can do the same thing with an AI system. In principle, put into it, nurture it at a young age, and then send it to the world.
That's very interesting. I think that's a good distinction to make between aliens on ships, biological aliens coming down versus AI probes. That seems much more likely.
I call them AI astronauts.
Yeah, I like that. So going back, you said before you got really interested in alien life, you were writing books about the first life, the first galaxies, stuff like how the universe formed. So what are your thoughts on the James Webb Space Telescope? Because as I understand it, this telescope is made with a specifically good capability of understanding the early universe.
Right.
So,
it's for a good reason, because when it was conceived, that was the main scientific goal, and I was on the advisory board. Back then it was called the Next Generation Space Telescope, NGST. And then they put James Webb into the title because they wanted to secure funding in Congress. And recently that got a lot of scrutiny because some astronomers said that they do not agree with the policies that James Webb, as the administrator of NASA, supported. But it was the Next Generation Space Telescope, and the idea was to look at the first light that was created by the first stars. Sort of the scientific version of the story of Genesis, and I worked on it. I was among the first to work on this subject. I wrote 2 books about it. So it's interesting that we can see how the universe was at early times. And the reason for that is that it takes light time to travel the distance. So if you look far enough, you see an image of what was there a long time ago. And if you go far enough, you can see what happened at the beginning of the universe. And by the way, this is not always true, because if you look far away, maybe things that were far away behave differently than things close to you. But the thing about the universe is it had roughly the same conditions everywhere. It was prepared, by the way, that is amazing, that the universe on very large scales is looking pretty much the same everywhere.
One of the things that kind of makes it hard for me to imagine, we say, we have this amazing telescope, the James Webb Telescope. It can look back at the early light. and as we know, the universe is expanding
Right.
from a single point,
Not a single
or the Big Bang, whatever
no, just
that
think
was.
about it as a cake that is rising, and you have raisins in it. So as the cake is rising, the raisins are separated from each other.
Okay.
But the cake could be infinite. It doesn't need to be coming from a point. It could be rising everywhere.
Well, but the BigAng theory, as I understand it, was that everything was mashed together.
No, just think about it. The cake initially was much denser, and as it's rising, it gets fluffier.
But there was one moment where everything expanded.
Yeah, so if you
and
go
was
back,
super hot and was faster, right?
because if you go back in time, again with the cake analogy,
Yeah.
you go back in time, if the expansion is continuing since the beginning, then all the raisins will be on top of each other and you end up with an infinitely dense cake. But it could still be a very big volume that is infinite density, and that is called the Big Bang.
Okay, because it's like if you look at any direction
Right, it's the same.
of the space sky, you're looking back at the Big Bang,
Yes.
and that's what's so weird to me.
You know, it's like
But
an
the cake analogy, I guess, makes sense when everything is expanding.
Yeah. So it's everywhere.
could have
the
been
same.
anywhere, yeah.
It's everywhere the same. And by the way, that by itself is a real puzzle. How come the universe was prepared initially in a simple state where the conditions were roughly the same everywhere? You know, very often we talk about the fact that the universe started simple because there were no planets, no stars, no objects. It was a soup of elementary particles, very hot. And then it cooled off as it expanded, and then objects started to form as a result of gravity. Gravity brought together the material that was dense enough to come together. So the cosmic expansion reversed in those regions that were dense and made galaxies like the Milky Way, and the gas fragmented into stars like the sun, and then the debris from the star like the sun made the planets that we are sitting on, like the Earth. So that's how things came to exist. But it's a transition from simplicity to complexity. And what I say is it will not continue like that, because eventually, the stars, like the sun, will burn all the nuclear fuel they have. They will destroy life on the planet like the Earth around them. So then the planet will become simple again. It will be just a rock with a burnt up surface.
Because there's a period of chaos, and then again, simplicity.
And the universe is also expanding, so we will be surrounded by vacuum. In fact, the expansion is speeding up, so there will be only our galaxy surrounded by nothing. And that also is a simple state. It's just like in life. You start as a baby, that's a simple initial state, because the baby, doesn't know much. And then you become an adult, so you're more complex. But eventually you end your life also in a simple state. And there is some similarity between the elderly and an infant. They are both helpless. So the initial state is simple. You go through a complex system called adults. They do a lot of damage to the world sometimes. And then you end up dead. Okay, so that's simple. And so the same will happen to the universe. I mean, now we are sort of at the peak of complexity. We should enjoy the party when it's going. Right. When there is life here on Earth, we should keep it as long as we can. Enjoy the
we can even see other stars, which is eventually something that won't be possible. Right?
Exactly, it will be darkness eventually.
People of the distant future will think they're alone.
Yeah, I mean, trillions of years from now, 10 trillion years from now, all the stars, all the lights will turn off.
Right.
So, I mean, stars like the sun will live maybe for another, few billion years, depending on when they started forming. And then the smaller stars, which are more abundant, like the nearest star, Proxima Centauri, they could live for trillions of years. So that's like 100 times longer, or up to 1,000 times longer. But within 10 trillion years, all the lights will turn off. So it's like, think about a party with all the lights turning off eventually. It will be darkness. We will be surrounded by vacuum. That's like death, basically. It's sort of a simple state.
Or what I was referring to is I've heard that like because of the expansion, the space-time itself is expanding.
Yeah.
That there will be a point where the expansion is faster
It's
than light.
right now, yes.
So that means that like I'm not talking about like stars burning all their energy, but that the fact that their light is incapable of reaching us because they're moving away faster than
That's
their
right.
light can travel.
So what happens, we realized over the past 2 decades, cosmologists, people that study the universe, we realized, and there was a Nobel Prize for that, actually given to 2 graduate students from my department. I was chair of the astronomy department at Harvard for 9 years, the longest serving chair. And so 2 of the students discovered that the expansion of the universe is accelerating in time. So in fact, it's speeding up. So that means if you look at a distant galaxy, it's not just receding away from us, but the speed by which it's receding is growing over time. So eventually it will exceed the speed of light. And that means that light from that galaxy will never reach us beyond a certain age.
Right.
How is that possible? According to Einstein's theory of gravity. It's just like if a friend of yours holds a cell phone, tweets, and you see the tweets and so forth, and then goes into a black hole. Okay, so what happens? There is around the black hole there is the so-called event horizon. That's sort of the surface inside from where you can't really receive any signal. Okay, it's just like the walls of a prison. So when your friend approaches that, once it crosses that boundary, any signal that the friend sends you will never reach you. Okay, so then you lose contact. So what you see from a distance is the friend, just like in an old Western movie, the cowboy goes into the sunset at the end of the movie, and then the image freezes. So the same will happen with your friend. The image will freeze and will become fainter and fainter. And the frozen image will be of your friend at the point when the friend crosses the horizon. Basically, you can't get more information about the whereabouts of the friend after that. And so you end up getting a faint image that is frozen. And the same will happen in the universe. So all the galaxies we see now will freeze and will become fainter and fainter, and we'll see nothing.
And that had happened before stars start burning.
Yes.
Yeah.
That will happen in about when the universe will age by a factor of 10, when it will be about 100 billion years old.
I find that kind of difficult. When I was a kid, the prevailing theory was like the Big Crunch.
Right.
And to me, that was much more appealing because there was like this elegant quality that you find in nature where things kind of are just like beautiful and elegant and simple. And I love the idea of the universe crunching,
because
expanding, and that explains the Big Bang, where that came from.
it could be like a cycle.
Endless cycle.
And also you meet your friends every time they come back.
It's kind of beautiful and like godly. It's like almost like supernatural, right?
But
then we understand that it's actually something much, in my opinion, like kind of, I don't know, it's just kind of disappointing that's the truth. Like, it's called heat death, right?
Yeah.
It just expands and expands and expands until there's virtually nothing left.
Yeah, but nature, reality is under no obligation. There is no contract for it to make you happy.
Well, that's not fair. I'd like to renegotiate that.
You can live in the metaverse.
Yeah.
Okay, that will make you
sucks,
happy.
Unfortunately.
You can take drugs and ignore reality.
Drugs? Okay, now we're talking. That sounds... But is it possible that... is it possible that we're wrong about this heat death expansion of the universe?
Yeah, it's what I'm describing is what we know now. Okay, we know now that the universe is expanding, that its expansion is accelerating, that it's speeding up, and that the end would be the way we described it. Now, it's possible that something unusual will happen, like the reason that we are speeding up the expansion is because there is a force like repulsive gravity. So gravity attracts. That's why we stick to the ground, because it keeps us grounded, and we need to use chemical rockets to escape from Earth against gravity. And Newton discovered gravity because an apple fell on his head when he was in the orchard of his parents, right? Now, Turns out that according to Einstein's theory of gravity, if the vacuum has some mass per unit volume to it, if there is some substance in the vacuum, then you get negative gravity. Because according to Einstein, it's not only the mass per unit volume that matters, it's also the pressure. Not just the mass, but the pressure. And the pressure gravitates, and the pressure is negative for the vacuum. Okay? So it turns out that you get repulsive gravity. So if you imagine Newton being embedded in a very dense vacuum, the apple will not fall, but rather fly up faster and faster, speed up away from Newton, because there will be repulsive gravity pushing the apple away from Newton. And this repulsive gravity is what's responsible for the speeding up of the expansion of the universe, because what happened was, early on, matter was most important, dominant, very dense. But then as the universe expanded, matter got diluted. At some point, it got diluted so much that it went below the vacuum mass density, below, and at that point the vacuum started dominating, and then you start to see the accelerated expansion, which happened when the universe was roughly half of its present age.
Is this what they refer to as like the dark energy?
Yes,
dark
that's
matter?
the dark.
And this is something that's, you know, a big topic in
Well,
science right now, right?
It's really embarrassing, I should say, because I'm a cosmologist. I study the universe, and we get paid even though we don't know what we're talking about. I'll explain. So 1933, an astronomer in Caltech called Fritz Zwicky discovered dark matter. How did he discover? He looked at galaxies in a cluster, in a group of galaxies, and they move around. And he realized that if there was only the matter that we are familiar with, in the form of stars and gas, then it wouldn't bind those galaxies. They move so fast that they should move out of the cluster. And then he reasoned that there must be more matter to keep them bound. And he called it dark matter. Okay, that was 1933. For 40 years, this idea was completely sidelined by the mainstream of astronomy. Speaking about the mainstream being open to evidence, it's very easy to ignore it. So people
Why did they ignore it? Just it was
why?
too
Because
weird.
we don't see dark matter in the solar system.
Yeah, it was
you
too
know,
weird.
I mean, we think that what we see around us must represent the entire universe. Okay, we don't see dark matter in the solar system because we are made of matter, that is ordinary. And I should say also, we thought that the sun is made of the same matter as the Earth. That was the prevailing thought until 1925, exactly a century ago, when a young scientist, she did her PhD, Cecilia Payne-Kapashkin, the first PhD in astronomy at Harvard University. Was by Cecilia Payne-Kapashkin. She was at Radcliffe at the time and did it in collaboration between the Radcliffe and Harvard organizations. But and she discovered that the sun is made mostly of hydrogen, based on analyzing the light coming from the sun. And in her PhD defense, the most distinguished expert on stars at the time, highly respected, the director of the Princeton University Observatory, named Henry Norris Russell, dissuaded her from including this statement because he said, that is impossible. We know that the sun is made of the same material as the Earth. Therefore, she took it
Meaning
out.
what? Like, what does that mean, the same material as the Earth?
Meaning the Earth is mostly iron and
Just like
heavy
a planet,
elements.
just a
yeah,
planet,
just like a
we
planet.
know. Okay.
But he was wrong because it took him 4 years to do his own studies and realize, and then he published a paper saying...
He stole her idea?
He basically said, yes, the sun is made mostly of hydrogen. Now...
Did he credit her?
Yeah, I think he mentioned her, but the strange thing is, I have a colleague from Harvard that was in a visiting committee at Princeton University a couple of decades ago, and the chair of the Department of Astrophysical Sciences at Princeton said that we have a long and distinguished tradition of astronomy at Princeton. For example, Henry Norris Russell discovered that the sun is made mostly of hydrogen. So my colleague corrected him and said, no, it was actually someone else.
Yeah, not exactly.
And and so that was the first mistake about the composition of things. But then it turns out that most of the universe is made of stuff that we don't find at all in the solar system. And it's called dark matter. And only in the 70s, astronomers like Vera Rubin and others confirmed what Zwicky claimed all along, that there is dark matter making up by now 84% of the matter